We have a problem here that we're going to solve using the quadratic formula, but I hope you notice that it's not exactly like any quadratic formula problem we've worked so far, because the exponent is higher than a 2 for starters. So let's go ahead and subtract the 2.9. We know we need to get everything on one side and 0 on the other. Now the next step is recognizing that when I go to factor this, if I could factor it, I can't factor it, but if I tried, I would have x squared and x squared, right? There'd also be some numbers here in the front if I could factor it. But when I get down to the end, I'm going to have x squared and some constant equals 0, right? I'm going to be solving for x squared here, not x. So you know when we write the quadratic formula, we always write x equals negative b plus or minus da da da. And it's because we're finding a single value of x. And what I'm saying I'm going to do different here is that I'm going to be solving for an x squared. Right, so this holds true if the powers go up to 6 or 8, it'd be x to the third. If it was x to the 6th or something like that, we wouldn't go that high. But anyway, that's the gist of this problem, is that you do apply a quadratic formula, but you just apply it and you get x squareds at the end. So let's apply the quadratic formula here. So I'm going to do, again, x squared equals negative, and then b is negative 1.5 plus or minus the square root of negative 1.5 squared minus 4 times 3.8 times negative 2.9, and we're going to divide all of that by 2 times 3.8. Alright, so let's work through these numbers here. Double negative of 1.5 is positive 1.5 plus or minus the square root of 2.25. And now here I have two negatives, negative 4 and this negative 2.9. That's two negatives become positive. And now the product of these three numbers is 44.08. And then I divide all of that by 7.6. All right, let's find out what 2.25 plus 44.08 is. All right, 1.5 plus or minus the square root of, all right, that's 46.33. And we're going to divide that by 7.6. All right, so now I have square root of 46.33. Let me go ahead and find the square root of that number. And it's 6.8066. Let me just grab that many decimals. So this is 6.8066. All right, so my two solutions here are going to be x squared equals 1.5 plus 6.8066 over 7.6. And I have 1.5 minus 6.8066 over 7.6. All right, so let's go ahead and do this first one here. 1.5 plus 6.8066 is 8.3066, and we're going to divide by 7.6. So I get 1.09297. All right, now on this side, I have 1.5 minus 6.8066, and I'm going to divide that by 7.6. And so there I get negative 0.6982. All right, now keep in mind these are x squared values. So if we want to find x for those two values, let's go over here and break it up. We have x squared equals 1.09297. If we take the square root of both sides, remember when we do square root method, we need to do plus or minus whatever this result is. So 1.09297, and take the square root, and I get 1.045. All right, it wants 3 decimals for the final answer, so plus or minus 1.045. That's two of my solutions, a positive 1.045 and a negative 1.045. Now on the other side, I have x squared equals a negative number. All right, so for this question, if we take square root of both sides, we're going to be in trouble because these are imaginary. All right, so in this case, we're going to discard these imaginary numbers. They are not part of the solution for this. I understand there may be some confusion because when we do quadratic formula with a regular x squared, we do process imaginary numbers as potential solutions. But here, since this is x to the fourth and we're solving for x squared, it's not possible for that to be true. So our two solutions here will be 1.045 and negative 1.045. And those are the two solutions you would enter here in the box.